Hello, in this video, I will show you how to perform AM modulation and demodulation using LT-Spice. AM or amplitude modulation is a technique widely used in communication systems. AM modulation is a process of varying the amplitude of a carrier signal in accordance with the amplitude of an information signal. The carrier signal is typically a high frequency signal, while the information signal is usually a low frequency audio or data signal. After completing our circuit, we run the simulation and observe the AM signal on the oscilloscope. Okay, this is a demodulating signal, and this is AM modulation signal. As you can see, the information signal causes a variation in the amplitude of the carrier signal. Our second circuit, we have sinus signal creator and AM modulator. Let's run. Okay. This is our message signal, and this is AM modulating signal. That's all.
I will be presenting on AM modulation. In my presentation, I will first explain what AM modulation is, how it works, and its importance in communication technologies. Then I will tell its advantages, disadvantages, and some of application. How AM works? Amplitude modulation is a technique used in electronic communication, most commonly in radio broadcasting. In AM, the amplitude of the carrier signal is varied in proportion to the waveform of the input signal. The frequency and phase of the carrier remain constant. Signal is a combination of the carrier wave and sidebands, upper sideband and lower sideband, which carry the actual information, the modulating signal. Characteristics of AM: carrier signal is a high frequency and unmodulated waveform. Sidebands are frequencies created due to the modulating signal. The frequency range extends both above and below the carrier frequency. Bandwidth: the bandwidth of an AM signal is twice the frequency of the modulating signal. Advantages of AM: simplicity, range, and wide usage. Disadvantages of AM are power inefficiency, susceptibility to noise and interference, and limited audio quality. And application of AM: AM radio broadcasting, aviation communication, two-way communication, and television. So it's my homework. We will run. Yep. Thank you.
Hello teacher, my name is BELİNAY İNAN. I am in the Electrical and Electronic Engineering for 100 English class. Today we will explain amplitude shifts keying with Berkay AZAK. S modulator. How it works? Let's learn about the working of the S modulator. The S modulator block diagram comprises of the carrier signal generator, the binary sequence from the message signal, and the band limited filter. Following is the block diagram of the S modulator. The carrier generator sends a continuous high frequency carrier. The binary signal from the message signal makes the unipolar input to be either high or lower. High or lower. The high signal closes the switch, allowing a carrier wave. Hence, the output will be the carrier signal at high input. When there is a low input, the switch opens, allowing no voltage to appear. Hence, the output will be low. The band limiting filter shapes the pulse depending upon the amplitude and phase characteristic of the band limiting filter or the pulse shaping filter. Characteristic. In S modulations, a carrier wave uses any sinusal wave is modified in accordance with the digital message signal. The amplitude of the carrier signal is changed between two predefined values. 0 and 1 represent binary depth. This is a photograph. The carrier wave is represented by continuous signal. The carrier's amplitude changes between two levels, particularly 0 and 1. When the input date is 0, amplitude might be lower. And when the input date is 1, the amplitude could be higher. The changes in amplitude affect the carrier signal in accordance with digital signal. This modulation technique is simple but can be susceptible to noise and interference, which can affect the accuracy of the received data. Advantages. 1. There are various advantages of using SSM modulation techniques. The over is on one of the simplest modulation techniques, which makes it easy to implement in both analog and digital systems. It is a cost-effective modulation technique, which is one reason for its widespread use in various applications. It's compatible with various transmission media, including radio wave, optical fibers, and wired communication systems. It is efficient in terms of bandwidth utilization, as it only requires the levels of amplitude 1 and 0. Disadvantages. 1. AZAK is more sensitive to noise and interference compared to other modulation techniques like frequency shift keying or phase shift keying. Fluctuations in the amplitude caused by noise can lead to errors in data recovery at the receiver end. 2. Bandwidth interference. As can be less bandwidth efficacious compared to other modulation techniques, it requires more bandwidth because it uses changes in amplitude to encode data, which can limit the number of bits transmitted in given bandwidth. Power inflations. Transmitting signal at varying amplitudes requires more power compared to constant amplitude transmission. This can be a disadvantage in signals where power efficiency is critical. Limited data rate. As is generally limited terms of achievable data rates compared to other modulation techniques, these limitations arise from the constraints on how fast the amplitude can be changed without distortions. Signal to noise ratio sensitivity asks performance is highly dependent on the signal to noise ratios. As the ratio between the signal power and noise power decreases, the accuracy and the reliability of that transmission can be significantly affected. 6. Lack of phase or frequency information. AZAK only usually changes in amplitude to represent that, unlike other modulation techniques that use phase or frequency changes. These limitations might make it more vulnerable to certain types of interference and distortions. Applications. 1. of the important application of S has been mentioned below. 2. Low frequency applications. 3. Industrial network device. 4. 3. Pressuring monitoring systems. 5. Wireless based stations. Uh, now my friend Berkay will explain the protest driving.
Hello, sir. My name is Berkay from the Electronics Engineering Department. I am a third class student. I'm gonna talk about the amplitude shifting modulator circuit analysis. The amplitude shifting is a digital communication method where the amplitude of the carrier signal is varied to transmits information, and in other words, if the bit to be transmitted is 1, the amplitude of the carrier signal is set to the 1 value, and if it is 0, is set to another value. Let's look at the circuit analysis. The 4016 chip contains 4 independent analog switches in the circuit. These switches are used to vary the amplitude of the carrier signal according to the input signal. By activating different switches according to the 1 or 0 values in the input signal, different amplitude signals are obtained at the output. The resistors are used to adjust the operating points of the switch and determine the amplitude of the output signal. The signal source generates the carrier signal. This signal is usually a sine or cosine wave, and I used a sine wave on the circuit. At the output, an amplitude modulated carrier signal is obtained. This signal can be transmitted via an antenna or given as an input to another circuit. When we examine the circuit operating system and operating principle, the output signal or digital data controls the switch in the 4016 chip. When the input is 1, one switch is activated and the carrier signal passes directly to the output. When the input signal is 0, a different switch is activated and the carrier signal is attenuated or cut off completely. The active switch changes the amplitude of the carrier signal, thus at the output different amplitude signal corresponding to the bits in the input signal are obtained. The circuit, as a result, this circuit is a simple amplitude shifting modulator. The digital data in the input signal is converted into an analog signal by varying the amplitude of the carrier signal. In this way, digital information can be transmitted over long distance at radio frequencies. And when we turn on the circuit, we see this you can see that there's a modulated signal. Let's change the tension of the circuits.